Welcome to my week 8 problem number 4 video explainer. So just a background of the problem. So recently an image was accidentally released from SPY satellites, and the SPY satellite is known to have a mirror with an effective diameter of 2.4 meters, and the image that was taken from a distance of 382 kilometers, and we are going to assume the aperture of the mirror is 2.4 meters, and we're going to take the wavelength of visible light to be 550 nanometers. So now that we have those variables out of the way, we can move on to solving the problem. So the first part asks, so assuming that the resolution of the SPY satellite is only limited by diffraction, we use the Rayleigh criterion to estimate the angular resolution of the detector. So we know that the angular resolution, in this case theta, is going to equal to 122 times the wavelength over the aperture. And we were given that the wavelength in nanometers, so we convert that into meters by multiplying by a factor of 10 to the negative 9th over the aperture of the mirror, which was 2.4 meters. And after we divide that to find that ratio and multiply it by the factor of 1.22, we find that the angular resolution is going to be 2.796 times 10 to the negative 9th radians. For the second part of the problem, we're trying to find the corresponding spatial resolution of the satellite for objects on Earth. And we also want to know whether or not it'd be sufficient to read the ULO logo in the end zones of Auckland Stadium. So we can use the equation d equals x theta, where d would be the distance separating the two objects, a distance x away. And we are given that distance x that the picture was taken from. That was 382 kilometers, so multiplying by a factor of 10 to the third, or 1,000, to put it into meters. And for that angular resolution, that angle that we just calculated in the first part of the problem, plugging those in, we find that the distance, or in this case, for the spatial resolution of the satellite, we find that is going to equal to 10.68 centimeters. So in this case, we can conclude that we can see the logo. And finally, the last part of the problem states that some news reports said that the image had a resolution of better than 10 centimeters. Is that consistent with your calculation? So more or less, in this situation, 0.68 centimeters isn't necessarily a negligible distance away. However, given just the background of the problem, we can conclude that the value is consistent of news reports. And some of the tricky parts of this problem, for me specifically, involved finding out whether or not we can see the logo on the field, and also, I guess, just interpreting the last problem, because it's somewhat ambiguous. And other than that, this just relates to what we've been doing in class, in this problem in particular with the Rayleigh criterion, and just more types of wavelength problems. So yeah, thank you.